Hey guys, today what we're going to do is we're going to have a look at this lesson one, which is Introduction to Decimals, a little bit more closely. If you're struggling with this topic, hopefully throughout the course of this video, it's going to clear this up for you. What you need is you need something to write with, because I'm going to get you to do some questions throughout this video, and hopefully by the end of it, you're going to be a little bit more confident with the content that we're working on here. So let's have a look here. We're doing Introduction to Decimals, and we're looking at decimals, and we're looking at place value. We're going to talk about that word, or those two words, place value, a little bit more in a minute. So during this lesson, we're going to introduce the topic of decimals, okay? To understand decimals, we first need to comprehend their place value and be able to identify where individual numbers sit on the number line. So we're going to look at different decimals, okay? We're going to try to identify which ones are greater than or bigger than, and which ones are less than or smaller than the other, okay? So in this lesson, we're going to do three main things. And the first one is we need to understand some of the symbols that we use when we're looking at a topic like this. And one of those, or a few of those, are the greater than or less than symbols, okay? Another one that we'll look at, which is very easy, is the not equal symbol. But we'll also have a look at the greater than or equal to, and the less than or equal to symbol as well. The second thing that we're going to do is we're going to convert some fractions to decimals, and the fractions are all going to have a denominator that is a power of 10. So that's actually going to be quite simple and straightforward, because we're going to have a table that we can use that will make that a lot easier for us. And the third one is we're going to be interpreting some worded decimals. So you're going to have to look at some numbers that are written out into words, okay, and you're going to have to turn them into a digit, okay, or a number of digits. Okay guys, so the first thing that we just need to go through is we're going to talk about these symbols. So here are the symbols that we're going to learn about today. So we're going to look at greater than symbols, we're going to look at less than symbols, we're going to understand how to compile a sentence when we talk about those, and our crocodile down the bottom is very important to us when we're talking about these sentences. We're going to look at the greater than and less than or equal to symbol, okay? And we're going to look at the not equal symbols, okay? So we've got 5 symbols that we need to learn, and hopefully we will understand these by the end of this lesson. Okay, greater than and less than symbols. Greater than and less than symbols are pretty simple to understand. So they look like this, okay? They look like this, and basically we use them in number sentences. And what I mean by number sentences is, let's just pick 2 digits, and I'm going to pick 2 and 6, okay? And if I was going to say that 2 is less than 6, what I would need to do is I would need to position my symbol this direction, okay? And I want to refer back to this little picture here, because this little picture here is basically how you read these sentences. So the crocodile, or in this instance, because obviously this is American, it says the gator. The crocodile always eats the big one. So when we're reading a sentence and the crocodile is eating this one to the right, it means that 2 is less than 6, okay? If I was to position my symbol this way, I would say that my first digit is greater than my second digit. Now, obviously, that makes this sentence incorrect. It makes it false. And a lot of the times when we're testing this, particularly in Year 7, you will be asked questions that are these true or false, okay? So the question will be, is this true or false? And the questions that you need to do today within this lesson are basically asking you just that. Are these statements, are these questions, these sentences that we make out of our numbers here true or false? So in order for this one to be true, we would need our crocodile eating the big one, which is 6, okay? The symbol determines how you read the sentence, okay? So if I've got a question that looks like this, let's go 0.05, is greater than 0.005, that means that that would be true. But we would change how we say this sentence if my crocodile was eating the other one. I would then say 0.05 is less than 0.005. So what these symbols actually do is they determine how you say and how you read the sentence, okay? The majority of the time we're asking you whether it's true or false, okay? And obviously in this instance, this number sentence would be false, okay? However, if we changed it around to that, it would be true, okay? So that's basically how greater than and less than symbols work. Okay, so now what you're going to do is you're going to practice some of these questions, and I'm going to give you probably about 2 minutes in order to do these questions, all right? There's just 4 of them, okay, and then we're going to go through the answers together. So remembering what we learned in the last slide, see if you can get through these 4 questions. Okay, so hopefully you got an answer for all of these questions, so let's go through it. Now remember, referring back to the last slide, the symbol determines how you read the sentence. So let's make sure that we're reading these sentences properly. So this one here is saying that the crocodile is eating the first one. So it's saying that 1.1007 is greater than, because our crocodile is eating this one, is greater than 1.107. Now, that is false, okay? That is false because we have an extra 0 in here, okay? We have an extra 0 in here, meaning that this number is larger than the first one. Let's have a look at the second one. It's saying 2.43 is less than, because our crocodile is eating the big one, okay, is less than 3.17, and that is absolutely true, okay? Our third one is saying that 0.987 is greater than 0.907, and once again that is also true because this number here is bigger than this number here. It's also important to note that just because this number has more digits than this number, okay, it's a longer set of digits. There's 5 digits in this number compared to 4 in the first one. It doesn't mean that it is a number that has a greater value, okay? Now, question 4 here is saying that 6.1073 is greater than 6.173. Now that one again is false. Okay, so hopefully you were able to get a few of those correct. Okay guys, so hopefully you picked up those first two symbols that we were looking at within this lesson, and now we're moving on to the next two symbols. Okay, so these are the last lot of symbols that you need to learn and understand, and if you know all of these, it'll get you through the first lot of questions for this unit. Okay, now these next two symbols are pretty simple. Okay, so we're looking at greater than and less than or equal to. Okay, so if we have a look here under our point number 1, okay, it says sometimes there will be a line under the symbols. This doesn't change much. You just have to add the words or equal to. So what do I mean by that? So if I have a question that looks like this, let's just say I've got 2.2 is less than or equal to 2.6, basically all I'd say is that that is indeed true. All we do is we add in the word or equal to. Okay, so 2.2 is less than or equal to 2.6. Okay, if I was to do it the other way around, okay, sorry, I just did that way, didn't I? If I was to do it the other way around, I would say 2.2 is greater than or equal to 2.6. Now, an example where you could use this, okay, is something that could look a little bit like this. Let's just say I've got 2 is 2 is less than or equal to 2.0. So our digits look slightly different. Okay, but obviously they are exactly the same. You could say that you could also use the equal sign in order to represent this as a true statement, and that would be absolutely correct. You could use the equal sign in this case. We could also have an occasion. Let's just say if I've got 0.2, I could say that that is less than or equal to 2 over 10, okay? And that would also be true, okay? But once again, I could also use the equal sign, all right? Now, number 3, the last symbol you need to be aware of is this one here, and it is the not equal symbol sign. Okay, so if I was to have this, if I had 3 is not equal to 5, then that means that this statement would be true, okay? It would be true. Okay guys, so time to have a bit of practice with this topic, okay, or with these symbols. I'm going to give you around about 2 minutes in order to go through these questions and answer them as true or false. Good luck. Okay guys, so let's go through the answers here. So the first one says 3.43 is less than or equal to 3.403. So once again, we need to identify which number here is greater and which one is smaller. So this number here is our smallest number, yet our symbol is saying that it's greater than or equal to 3.43. That is false. Okay, that's incorrect, that statement. So this next one here, it's saying that 7.3 is greater than or equal to 7 and 3 over 10. Well, that is actually correct because 3 over 10 equals 0.3. So that means that this statement is true. Now we're going to get into this after this topic, okay, or after looking at these symbols, and we'll start converting some fractions into decimals. Question 3 here says that 0.987 is greater than or equal to 0.9807, and that is also a correct statement. So that one there is true. And our last one here is saying that 6.1073 is less than or equal to 6.173, and this number here is smaller than this one here. So what it's saying there is true. Okay guys, so now we're moving on to converting fractions into decimals. And these ones are really easy to convert because of the fact that they all have a denominator that is a power of 10. Okay, so the questions that you're looking at today in your textbooks all have a fraction that has a denominator that is a power of 10. Okay, so let's have a look at some of the things that we need to know. So number one, use the place value chart. The place value chart is really, really important, okay? And it makes this topic super easy, okay? Number two, the last digit of the numerator goes into the place value of the denominator. So what I mean by that is if I have a fraction here, and let's say I've got 31 over 100, okay? I basically look at my place value chart and I look for my hundredths column, okay? And what I do is I find the last digit of my numerator and I'm going to place that here, okay, on my place value chart. And then obviously the 3 goes directly next to it, and then my decimal point goes there and I put a 0 in my units or ones, okay, and that's it as a decimal number, 0.31. Now it can get a little bit tricky if you have a fraction. Let's just say I've got 6 over 1,000, okay, 6 over 1,000. Then what I need to do is I need to put that 6 into the thousandths, okay, because it is the last digit of my numerator. Even though there is only one digit in my numerator, it is the first and it's also the last one, so we put the last one into the thousandths column, and then we've got to fill in some zeros, okay, so I need a 0 there, a 0 there, and obviously my decimal point, and then another 0, okay? So 6 over 1,000 would be 0.006 as a decimal. Now, sometimes you will also have whole numbers attached to your fraction, okay? So let's have a look at this one here, okay? I've got 21 and 6 over 100. Now, the first thing that you do is you always just deal with the fraction, okay? So my last digit of this fraction is a 6, okay? And my place value is 100. So I put the 6 here in the hundredths column, and then I put a 0 in the tenths, and now I look at my whole numbers, okay? Well, that is 2 tenths, so let's put the 2 there, and that's 1 1, so let's put the 1 in the units or the ones. So that number as a fraction, or sorry, as a decimal would be 21.06, okay? So using one of these is incredibly important and useful when you are converting fractions that have a power of 10 as a denominator and turning them into decimals. Okay guys, time to try and convert these yourselves. The place value chart is on this screen as well. It may be helpful when you're converting these. In 2 minutes time, we'll stop and then I will go through the answers. Okay, so hopefully you were able to get some answers for these. So let's have a look. So the last digit on this first one is a 7, and the 7 needs to go into the tenths column. So I put the 7 there, and obviously I have a 0.7, okay, 0.7. For my second one, I've got 7 and 3/10. So let's deal with the 3 first. So once again, the 3 goes into the tenths column. Okay, and then I've got my decimal point, and I've got 7 ones in this question as well. So that means my answer for that one is going to be 7.3. Okay, my next one here is 31 over 1,000. Okay, so I need to look for the thousandths column on my place value chart. So here it is here. Okay, the last digit needs to go into that column, so that's the 1, and then the 3 goes next to it. Now I need to put in a 0 also, okay, to give me an answer of 0.031, okay? And then lastly, I've got 2 and 9 over 100. So let's look for the hundredths place value up on our place value chart. There it is. And let's put our 9 there because it's the last digit of my numerator. Then I have a 0 that I need to fill in. And then obviously I've got a 2 in the ones column because it also has 2 holes. So that as a decimal number is 2.09. Hey guys, okay, the last topic in this is turning sentences of words, okay, which are numbers, into a decimal number, all right, into a decimal number that's written as digits, okay? So what I mean by that is basically here we've got worded decimal, so try to write the following as a decimal number. So there's just 2 here, and I've put a place value chart there. And I'm not even going to explain this one first. I'm going to get you guys to have a go at turning these into numbers, and then I'm going to give you the answers. So I'll give you around about 2 minutes to get these done, and then we'll come back and go through the answers. All right, so hopefully you were able to get a few answers with those. Now the place value chart is really handy with this as well, okay? So what I'm going to do is, firstly, I'm going to look at question 1, and it says 6 3/100ths, okay? So let's have a look at these, this first number first. So 6 is 6 ones, okay? 6 ones. So we just put that in our units down here, and then I have 3/100ths. So that means that I've definitely got 3/100ths here. But what about here in the tenths? Well, because it's only 3/100ths, it has to be a 0. So that means that my decimal number for that one would be 6.03, okay? Now, our second one is 7 323 thousandths, okay? 323 thousandths. All right, let's not worry about this at the moment. Don't let that confuse you. We're going to get to that in a second. Let's deal with the easy part first, which is the 7. So the 7 is obviously 7 ones. We just throw that into the units column there, and then it's done. Now we have 323 thousandths, okay? So let's firstly see what place value it ends on, which is thousandths. So we need to find that on our place value chart here. And we have 23 thousandths, which means, well, we have 323 thousandths. But the last digit that it refers to is the 3. And the 3 is the one that's going to go into that thousandths column, okay? The next one on from that is the 20, and it goes into the hundredths column. And then the next one, the next highest one, is the 300, okay? And that is going to go into the tenths column. So this number here is 7.323 as a decimal, okay? So that's where this place value chart is really handy for putting these back into decimal numbers, okay, if they are written as a sentence. Okay guys, so hopefully that has cleared this topic up for you a little bit and you feel a little bit more confident with the questions within here. Remember, if you have any more questions, please just ask me in class and we can go through some of the examples. Good luck.